Hello, my name is Ashton Dunn. Today I'll be talking to you about breadboarding. What is a breadboard, you may ask? A breadboard is a constructed base used to prototype circuits. Each breadboard has a positive and a negative on each side. You usually put the positive on one side and the negative on the other, but depending on the circuit, you might change that. The breadboard also has different numerical uh, ways of organizing it horizontally and an alphabetical system of organizing it vertically. This is used to help pinpoint the exact location you need to put a component. The numerical base values are all connected using a metal bracket. So all the ones are connected, all the twos are connected. This is because you want electricity to flow through, the ones, the twos. It just makes connecting different circuits together super easy. Each breadboard when working with a breadboard, you're going to be working with a bunch of different components. Some of these components include resistors, LEDs, capacitors, potentiometers, and I have some of them with me. This is a resistor. A resistor is used to help lower voltage and the amperage and the current so you don't overload your circuit. Each resistor has a different ohm of resistance. You can tell which type of resistor it is by the color coding on the ceramic right here. There's a cheat sheet used. I don't currently have the cheat sheet with me, so I'm uncertain about what type of resistors these are. There are also potentiometers, which is this right here. A potentiometer is used to lower and increase voltage. It is used, if you can see, it's hard to tell, but you can spin the top of this, and that will allow you to adjust your voltage. And this is used more for motor controls and stuff, because if you want to increase the speed of the motor, you have to have the voltage increase. If you want to lower the voltage or lower the speed of the motor, you have to lower the voltage. This here is a capacitor. A capacitor charges up with super high voltage, and then it releases it all at once. So with this, you could put in 5 volts. You can have it charge up, and it can release, it will release all that 5 volts at once. Big power surge. This here is an LED, a light emitting diode. You put electricity through it, it's going to turn on. Here on my breadboard, I have buttons. You press the button, and electricity will go through it. Electricity flows through these buttons diagonally, which is strange because most buttons, they kind of just go straight. And then I also have jumpers, which are used to connect different components without having to solder them together. There are also logic gates that you use. You combine different components, put them together on a breadboard to create a logic gate. There are ANDs, which means you have to have 2 inputs, an OR, which means one or the other input, or both. There is an XOR, which means exclusive OR, which means you can have either one or the other pressed, but you can't have both. A NAND, which is a NOT, which is the opposite of an AND, where you have to have neither of them pushed. A NOR, which means you have to have neither of them pushed. Or with the NAND, you can also just have one pushed. Sorry for that. And a a NOT gate, which is if you put voltage through it, it's just not going to go, or not voltage through it. if you have it connected to like a button or something, you can press a button and it's going to turn off. Or turn on. No, off. It's going to turn off. Sorry for that. Okay. I'll continue. These logic gates are often found in like your phone circuit. Hair dryers have these type of circuits. These logic gates are pretty much used in everything. Here on my breadboard, I have an AND gate, and I'll show you how that works. If you give me 1 second. Here, you press one button, doesn't turn on. You press the other button, doesn't turn on. You press both buttons, and the LED glows. A common tool used while breadboarding is called a multimeter. There are two different types. There's analog and digital. Today I'll be going over a digital multimeter because it is easier to read. Here on the multimeter you have different inputs. Here you have voltage, resistance, and over here you have amperage. Over here are all the different things you'll need to read. I'll turn it over to voltage when it turns on. Up here you can see it'll say AC or DC depending on what type of voltage you'll be working with. Today I'll be working with DC. With these two prongs, you're going to connect them to each side of your input or your output, or your input and your output. So if I connect it to my positive and my negative, my power supply says 5.1 volts, and on the multimeter it says 5.1. If you would stop freaking out. Okay. My inspiration for this speech came from Applied Technologies. I recently got an email asking if I would go interview there, and what they mainly do is they fix broken circuits. Thank you for watching.